verify the identity by transforming the left-hand side into the right-hand side. We have sine of theta over 2 divided by the cosecant of theta over 2 plus the cosine of theta over 2 divided by the secant of theta over 2 is equal to 1. Well, first thing I'm going to do to simplify the problem is I'm going to let x equal theta over 2, just so I don't have to write theta over 2 over and over in my analysis. I'll replace x again with theta over 2 in my last step. We're supposed to start by transforming the left-hand side, so we'll do that. We'll write sine of theta over 2 over cosecant of theta over 2 plus the cosine of theta over 2 divided by the secant of theta over 2. With my substitution, I can write this now as just sine of x over cosecant of x plus cosine of x over secant of x by substitution. If I use some of the basic fundamental trig identities, in particular the reciprocal identity for cosecant in terms of sine, I can write this. This is sine of x over 1 over sine of x, because cosecant of x is equal to 1 over sine of x. And likewise, using the reciprocal identity for secant, I can write that as 1 over the cosine of x. Those are by the reciprocal identities. For cosecant x and secant x. Now, if I multiply the top and bottom of this by sine of x, I will have sine squared of x divided by 1. Likewise here, if I multiply the top and bottom of this fraction by cosine of x, I'll have cosine squared of x divided by 1. And that's just by multiplying. Really, I could justify that by multiplying by the reciprocal. To divide by this fraction, I multiply by the reciprocal, sine of x over 1. So I'll just write multiply by the reciprocal here to divide by fraction as my justification. And now I'm essentially done, because the 1 is immaterial. Dividing by 1 doesn't change the value. And when I write sine of x plus cosine, or rather sine squared of x plus cosine squared of x, that's equal to 1 by the first Pythagorean identity. The well-known identity in trigonometry that says that sine squared of x plus cosine squared of x equals 1 for any angle x. Now, I said I was going to substitute back in for theta over 2, but it turned out I didn't need to, since my right-hand side didn't have any x's anymore in the first place. So regardless of the angle that I start with, I end up with 1, and I've shown that the left-hand side can indeed be shown to be equal to the right-hand side for all values of theta for which these functions are all defined.